All right, today we are going to crack a code. It's a code that's hidden in plain sight, a language you see every single day, but maybe you're not totally fluent in it. I'm talking, of course, about percentages.
I mean, you've seen them everywhere, right? That little number next to your phone's battery icon, a huge sign in a store window screaming 40% off. They're all over the news. And they seem simple, but let's be honest, they can be surprisingly tricky. But what if I told you there's one, just one, simple secret to understanding all of them? Okay, let's dive right in. First up, cracking the percent code. We're about to unlock that one fundamental secret that makes this whole thing, well, simple. And you know what? This secret, it's been hiding right there in the name this whole time. Percent. It comes from the Latin phrase per centum, and that literally just means per 100, or out of 100. That's it. Seriously, that is the entire concept in a nutshell. So that one simple idea, it gives us an incredibly powerful tool. I want you to think of the percent symbol, the little percent sign, as a direct command. It's an instruction that's telling you divide by 100. So anytime you see that symbol, you can just swap it out for /100. This is it. This is your secret key for decoding any percentage problem that comes your way. All right, so we've got our secret key. Now we can start doing some translation work. We can take this language of percentages and translate it into two other languages you're probably way more comfortable with already: fractions and decimals. Let's see this in action. Say you want to turn a percent into a fraction. Easy. You just use the key. So 16%, that just becomes 16 over 100. And you can simplify that down to 4 over 25. And what about going the other way? Let's say from a fraction back to a percent. You just do the opposite. Multiply by 100%. So 2/5 times 100%, that gets you 40%. See, it's a perfect two-way street. Now, what about decimals? Well, believe it or not, it's even more direct. Since percent means per 100, all you have to do is multiply your decimal by 100 and then slap that percent symbol on the end to show what you did. For example, take the number 0.26. You multiply it by 100, you get 26. You add the symbol, and boom, 26%. And here's a little pro tip. Multiplying by 100 is really just the same as moving the decimal point 2 places to the right. Super fast. And hey, going the other way, from a percent back to a decimal, is just as easy. We just go back to our secret key. 15% literally means 15 divided by 100, which gives you the decimal 0.15. See how powerful that one simple rule is? It just keeps working. Okay. Theory is great and all, but let's actually put this code into action. Let's use our new translation skills to solve a couple of problems you might actually see out in the wild. All right, here's a classic. You've probably seen this kind of question a million times. If 24% of 50 is m, what is m? Now that little word of in math, that's a clue. It almost always means multiply. So this question is really just asking, hey, what's 24% times 50? And this brings us to the core formula, the one you'll use for almost any percentage problem. It's simply this: the part equals the whole times the percentage. So in our question, the part is the mystery number m, the whole is 50, and of course, the percentage is 24%. Okay, so let's just plug those numbers in. We get m equals 50, that's our whole, times our percentage. And how do we write 24% in a way we can actually calculate? You got it, we use our secret key. We just translate it to 24 divided by 100. And when you run the numbers, 50 times 24 over 100, you get 12. That's it. 24% of 50 is 12. See? No guesswork, no magic, just simple translation. All right, ready to flip this on its head? Let's try a different angle. This time, we know the whole number, it's 85, and we know the part, which is 68. What we need to find is the unknown percentage, a. So to solve for a, we just have to rearrange that core formula a little bit. First, we need to figure out the relationship between the part and the whole. We do that by dividing 68 by 85. That's going to give us a decimal. Then, how do we turn that decimal into a percent? You know this. We just multiply it by 100. You do the math, and what do you get? 80. The missing value a is 80, so 68 is 80% of 85. See how it all just fits together perfectly? And by the way, this whole translation thing works for other operations too.
If you're trying to calculate, say, 1 plus 45%, you just translate that 45% to 0.45, and you get 1.45. Or what about 40 divided by 20%? Well, you translate 20% to 0.2, and 40 divided by 0.2 is 200. The principle is exactly the same every single time.
And just like that, you've done it. You've cracked the code. And I want you to realize this isn't just about passing some math test. This is about gaining a whole new kind of literacy for the world that's all around you. So let's just do a quick recap of your new code-breaking toolkit. Rule number 1, the big one, that percentage sign always means out of 100. Rule number 2, because of that, you can always translate percentages into fractions or decimals to actually do the math. And rule number 3, it all comes back to that one core formula, part equals whole times percentage. That's your toolbox.
And this is why this all matters so much. Whether you're trying to understand interest rates on a loan, make sense of statistics you see in the news, or just figure out if that sale is actually a good deal, percentages are, really, the language of the modern world. So I'm going to leave you with this thought. A few minutes ago, you might have looked at percentages as just confusing numbers. But now you have the key. You can decode them anywhere you find them. You basically have a new superpower. So the only question left is, what are you going to do with it?